I welcome Professor Jigwinder Singh. I also welcome all the participants in this session. Before the start of this session, a brief introduction about Professor Jigwinder Singh. Presently, Professor Jigwinder Singh working as an associate professor in the Department of Humanity and Management at Dr. B.R. Ambedkar, NIT Jalandhar. Professor Jigwinder Singh completed his BSc from Punjab University, Chandigarh, and MBA in Marketing in HR from Shivaji University, Kolhapur. PhD in Business Management from again Punjab University, Chandigarh. His main areas of research in marketing, consumer behavior, relationship management, consumer loyalty, social marketing, organizational change, and educator development. So he has published a number of research papers in reputed journals and conferences. He also supervised a number of PhD students. So today his topic is statistical tools, analysis of variance and multiple regression. So sir, now I request Professor Jigwinder Singh kindly start the session.
Yes, very good morning to all the organizers and the participants. So let me start with today's session. It is on statistical tools that we employ for the analysis of our data. Now, before I start with the topic, I would like to draw your attention on some of the important aspects of the research. Yes. So first of all, we need to understand that what do we actually mean by research? Because on a number of occasions, it has been experienced that we overemphasize on the tools or the methods. Okay, no doubt, we need to have the understanding about the methods. We should be well versed with the methods because we have to make interpretations from the data analysis by using the appropriate methods. But it is not the research actually. This is something which is given us nowadays by the machines. So before carrying out any data analysis, we need to keep in our mind that what is our research. So basically, if we look at the research, actually its meaning, then it has two important characteristics. One is it is a systematic, and second thing, it is an objective process. It is a process, first of all. It is not an activity, it is a process. This involves the series of activities. And these series of activities must be systematically performed, and these should be objectively performed. So we always need to keep our objective, research objective in mind. So if we keep our research objective in mind, only then we will collect data according to that research objective in the desired format. And then we will be only able to employ appropriate methods, tools, or techniques. So many times, whatever the problem we encounter is that the scholars gather data and then they go to the statistician for employing the appropriate tools. Now, if we have to employ any method, so first of all, we should be very clear that what interpretations we want to make out from from this data. Then there are certain methods that will help us in making those interpretations. But in order to employ those methods, the data should be collected in the desired formats. So that is why the entire research design should be kept in mind before carrying out the research process. So, because once the data has been collected and we desire some interpretations out of it, and we need to employ the method. So if data and data collection format and the method are not synchronized, or there is no harmony between these two, then it will give us the misleading interpretations, misleading information. So that is why it is very important that what objective we want to serve, so it should be kept in mind right from the data collection stage. So we need to have the clarity that I am collecting this data to fulfill this objective, and to make out these interpretations, what method, technique or tool I will employ in order to employ this, or making use of the appropriate software. So in what format should I collect data and then organize data? So it is a systematic means they, for example, first of all, we have the problem definition, the problem what we want to work on. Second thing is the literature review. Literature review helps us in understanding the concepts, the relationship between the concepts, the studies that have already been carried out, the contrary results, under what contextual factors those contrary results have come. Then we look at the research gaps. Then to fulfill those research gaps, so to fulfill some of those research gaps, so we frame our research objectives. Then we design our instrument, and then we select the area of study. It can be a field survey, it can be a field study, it can be in-lab experiments, etc. So then we have to make certain observations and we have to collect data. So that format is very, very important. In what format, on what scale we have to collect data. And then we have to employ the appropriate method so as to get the meaningful interpretations, finally to fulfill our objectives. So that is why this research is defined as a systematic and objective process that includes the identification, gathering, first of all, what type of data we require, then data collection, then organizing data in the desired format, and finally we analyze the data so that we can get the meaningful interpretation, and finally this information is disseminated for taking appropriate decisions. So whatever the tools we employ, so this comes in this process of analyzing data, in this activity. Now, many times we carry out research starting with a theory, or sometimes we may start with the observation and then we move on to the theory. So we have made out certain observations, then we have tried to understand some of the patterns, then we employ our understanding, our beliefs, which are the tentative hypothesis. Then we try to validate it either through surveys or through experimental studies so as to produce theory out of it. This is called inductive research. Or we can go in a reverse manner. We may start with the theory, on the basis of theory, we identify certain other contexts so as to test the validity of those theory in the desired context. So there we design hypothesis, we carry out observations, and then we try to confirm it whether it holds true or does not hold true in this context or not. So this is called deductive research. So either we start with the observation and try to conceptualize it or try to theorize it, or we start with the theory towards the context and try to confirm it in the different contexts. So another important thing is that whatever the tools we would be discussing today, these are research methods. And there is a difference between research methodology and research methods. Research methodology is a much wider term as compared to research methods. So research methods are used only for the data analysis. So methods of data analysis or making use of these techniques so as to establish relationships between the concepts, or we have to evaluate the accuracy. So, but as far as the methodology is concerned, methodology is a much wider term and a comprehensive term. So it includes the theoretical perspective. First of all, we make an epistemological stance that why we want to carry out a particular research. This is not something that we do at our own whims and fancies. It should have some significance. Okay. So if it has some significance, only then, because it has some merit, only then we proceed towards it. So first of all, we look at the merit of carrying out any research. So what is our epistemological stance? Why we want to carry out research? In every research, there are two important things. One is the concept and other is the context. So whatever we study in theory, so we understand about different concepts, and different concepts have the relations with each other. And this relationship between different concepts is finally, you can say, converges into the theory. So in theory, you see there are different concepts and the interrelationship between those concepts are discussed. Then we see whether this theory holds true in different situations. So when we see that this theory, any particular theory holds true in some of the situations and does not hold true in some other situations, or you may have to add more concepts or delete some of the concepts. So then you re-theorize those things. So first of all, we have the theoretical perspective and the context in which we would like to test that theory, or from the observation we would like to develop the theory. Then we make use of instruments. It can be experimental setup. It can be questionnaires in case of survey studies, and techniques that includes the ways of collecting information or data, then organizing it. And then finally, we carry out the analysis or the data analysis part. So in the data analysis part, we make use of the research methods. So this is the fundamental difference between research methodology and research methods. Now, as far as the different types of research are concerned, so there are three main types of research. One is exploratory research, other is descriptive research, and third is causal research. Now, as far as exploratory research is concerned, it is meant for making new insights. If exploratory means if we have to explore something. Now, as I have discussed earlier, in case of inductive research is more of exploratory in nature, because we have made some, you see, we have come across some unique observations that we have not witnessed earlier. So then we try to understand about that phenomena, about that happening. So exploratory research is meant for making new insights. So that's why it is very flexible. So just I have mentioned at the bottom that it is based upon observations, some ethnographic, okay, that we experience with other people. Then second thing is descriptive research. In descriptive research, we do not explore the concepts. So concepts are already there, theories are already there. So we employ those theories so as to describe their characteristics or describe their functioning in the different contexts. So we understand, let's say, that y is our dependent variable and it is influenced by three independent variables A, B, C. Now this is already theorized. Now what happens? A, B and C may influence the dependent variable y in some order, that A may have the more influence, then B may have the moderate influence, and C may have the relatively less influence but significant influence. So in one setup, in one situation, we have understood A, B, C have influenced Y. And in some order, there is some ordinal setup in which these three independent variables are influencing the dependent variable. Now we have employed the same thing in some other area, in some other context. Now there we see the difference in the order. Okay, B may be more influential as compared to A, or C may be moderate, may be influencing to the moderate extent. Now, for example, let's say I take a very simple example. The dependent variable is the crop yield. Now there are three inputs. Let's say one is seed, the quality of seed. Second is the fertilizer. And third is, you can say, the quality of soil. So these three factors are contributing to the yield of a particular crop. So in case of one crop, so let's say seed is playing the highest role, followed by, let's say, fertilizer, then followed by the fertility of soil. But in case of some other crop, the fertility of soil may play the highest significant role as compared to seed and fertilizer. So the context has been changed. Okay, the characteristics of influence of different independent variables have been changed. So when we try to describe these characteristics or functions, then our research becomes descriptive in nature. So because theory is already in place, that's why we understand, yes, this yield is primarily dependent upon these three independent variables. So that is why our research, because the concepts and the relationship between the concepts are already there. So our research is highly pre-planned and it is highly structured. In case of causal research, so we try to establish cause and effect relationships. So what we do, we go for the manipulation of the independent variables. So let's say we manipulate. Okay, we either increase the intensity of something or decrease. Now, for example, let's say you vary the temperature conditions in certain setups. Okay. Or you add on some, let's say, catalyst, for example. Then you see whether the reaction rate has increased or it has been slowed down. So you carry out, when you carry out experiments, in experiments, you manipulate the independent variables and then you see the effect of those manipulations on the dependent variable. So very first thing is that whenever we have to decide about our research methods, so first thing is that we should be very clear that what are our objectives. So not only the research objectives, but you need to be clear about the research design, whether my research is exploratory, whether my research is descriptive, whether my research is causal. So I have used these terms. So theory is the general proposition about certain observed phenomena. So it is more generalized because we employ it many number of times. And then when we see the relationships holding true in number of multiple situations, then we try to generalize those relationships between the concepts. So we theorize. As far as the concept is concerned, it is a basic unit of theory development or abstraction of reality. So this is the generalized idea about the class of objects. Now, for example, let's say in our social sciences, whenever we see the relationship between 2-3 things, let's say one is the attitude, then intention, then behavior. So we say that first the positive attitude is developed to something, then people develop the intention, and then there are certain environmental factors along with the intention of the individual. So they are translated into the behavior. Now these three, the environmental factors, you can say attitude, intention, etc. These are the different concepts. And then we see the relationship, whether someone is moderating, whether someone is complementing the effect of other, whether someone is, let's say, mediating the effect of one on the other. So when we see these relationships between the concepts, so that becomes the theory. So proposition, I have used this word. This means the relationship between the concepts. It is called proposition. So this is a simple example that when we pick up the theoretical perspective, then theory is existing in the abstract manner. So there is high degree of vagueness you see. Now, for example, let's say I use the word asset. Now, when I use the word asset, it is abstract in nature. So when I use the word, what type or type of asset, or I go into the precise, you can say, specifications, that it is a punching machine, for example. So that means I am talking about a particular context. So when you when you put forward the theoretical perspective, then you will find the theoretical perspectives in the abstract nature. But when you will employ in a particular context at the empirical level, so then you will make use of the specific words, that what asset, what machine, etc. So in some of the studies, we make hypotheses and we test those hypotheses. Now, what are these hypotheses? Now, hypotheses are based upon our research questions. So these are the propositions. Just I have used the word proposition, relationship between different concepts. So what is proposition? the relationship between different concepts, and some of the relationships are there which are unproven. So those unproven propositions means hypothesize means assumed, our statements, our suppositions that may tentatively explain certain phenomena. Means one relationship holds true in one context, and the second context may be different from the first context, but has certain similarities with the first context. That's why I assume that this relationship should also hold true in this context also. So relationship between A and B, there is a strong association in context 1. So in context 2, even though it is a different context, but by and large, it has lot many similarities with context 1. So I also assume that this relationship should also hold true in the second context, but it is so far unproven. So tentatively explains the phenomena, but still it is an unproven proposition. So I would try to test it empirically by carrying out a study in that particular context. And this context is the area of interest for that researcher. So whenever I make this statement, yes, this relationship holds true, okay, even though it is unproven, because I want to test it in the empirical investigation. So this is hypothesis, which is a possible answer to the research question. So either this hypothesis may be accepted or it may not be accepted. Otherwise, in simple words, you can say it is just a predictive statement, but must be objectively verifiable. So anything which is not verifiable, so that should not be framed as the hypothesis. That's why I told you in the previous slide, in case of exploratory research, because we are still exploring. So we do not have any this sort of proposition which can be objectively verified. So that's why in exploratory research, there are no hypotheses. Then another important thing is that whenever we carry out any research, now as far as the population is concerned, in most of the situations, not in all situations, the population is large enough. But we try to define the parameter of the population by taking a sample out of it. So this sampling is very, very important. I will not go into the deep details of the sampling, but sampling is very, very critical, that it should be the true representative of the population. Now, for example, let's say, now many times you will see, and in the times to come, that people carry out opinion polls or exit polls particularly. So now they make predictions on the basis of their survey, in which they select a sample of maybe 10,000 people or 20,000 people. On the other side, let's say in a state of Punjab, so you see there are more than 1 crore voters. And they make predictions only from the responses taken from, let's say, 10,000 people or 20,000 people maximum. Many times it can be 50,000 in some of the studies. Okay. So making projections by taking responses, by making projections of people around 1 crore by taking responses only from 50,000 people. And if it is nearly true, or 80% true, or 90% true, or 70% true, even 75% true. So it would come true if that sample is the true representative of the population. So many times what happens? So they take different samples. They take different samples. Now, when they take different samples, they take different samples from the different strata, of the population. Now, similarly, for example, if you have to check the fertility of soil, then you may not take all the samples only from one district or from one village. So they would be taking samples, let's say, from Malwa region, let's say, okay, or some of the samples from the Bate region, some of the samples from Bathinda belt, let's say, some of the samples from, let's say, Amritsar, Gurdaspur, let's say, because they understand that the variety of soil may differ and it contributes a lot. It is important. Similarly, they take sample from the different respondents of different strata, maybe of different classes, you can say different demographics, okay, maybe let's say male and female, people of different occupations, people of different castes, people of different religious faiths. So why do they take so? Because they understand that this plays an important role in the overall dynamics. Otherwise, if the same agency has to carry out the survey, let's say in any European country, so their basis of classification or their strata identification would be entirely different as from what they are doing here in India, because their dynamics is different, for example. So the point here is, now what we see, we have taken a sample from one site and taken the mean. Then we have taken the sample from the other site and taken the mean. We have taken third sample from the third site and taken its mean score. Now we will take the means of all the samples. That will tell you the mean of the population. So this is called sampling distribution, and also standard error comes here into this. That this is a probability distribution of all the possible means of samples, taking the means of samples. So that will be more nearly equal to the population mean. And then there can be some deviations also. So then we take the standard deviation of the distribution of the sampling statistic. So that is called standard error, because some of the observations may deviate to some extent or to the large extent from the mean score, but it should not be too large. So there we make use of these terms in case of samples. Estimate is the specific observed value of the statistic. Estimator is the sample statistic that is used to measure the population parameter. So these are the normal terms that we employ in the, or you can say, are the terms of the statistical jargon. When we make use of, you see, these statistical tools, then on the basis of the results that we get after analyzing data, we either accept the hypothesis or reject the hypothesis. Not accept the hypothesis, you can say. Then there are two types of errors. Then here we see that what type of error is the researcher is willing to commit, and what type of error the researcher is willing to commit. This is one thing. And second thing is, to what extent a researcher is ready to commit that error. Now, first is type 1 error, rejecting a null hypothesis when it is true. And second is type 2 error, accepting a null hypothesis when it is false. Now, these are also called as alpha errors and beta errors. Type 1 error is also called alpha error, and type 2 error is also called beta error. Now, what is this alpha error? Alpha error is basically also known as the level of significance. Sometimes you see, you also mention that these results are significant at level of significance 0.05 or alpha is equal to 0.05. Nowadays, we make use of p-value, which is 0.05. So p-value, alpha error, Ti-1 error, it is one and same. Now, first of all, what does it mean? Because ultimately, whatever the tools we would discuss, so there we also make use of these things. Now, what is Ti-1 error? Rejecting a null hypothesis when it is true. Now, first of all, we hypothesize something. Now, let's say I take a very simple example that there are 3 sections of a class. Let's say 3 sections A1, A2, A3. Now, we have taken into consideration their mathematics score, that how much marks each student has scored in mathematics. So we are considering the entire class. So we have the data for the entire population. Let's say first year students, 3 sections, A1, A2, A3. So what happens in case of A1, we found the mean score is 55. In case of A2, we have found the mean score is 60. In case of A3, we have found the mean score is 50. The number of students are different in 3 sections. In case of A1, the number of students are 40. In A2, number of students are 25. And in A3, number of students are 50. Now, we assume that the students of all these 3 sections have the equal proficiency in mathematics. This is the null hypothesis that we assume. That the mean scores, what they have scored in mathematics, are equal. They have the equal proficiency in mathematics. Even though their means are different, but we have to see whether these are statistically different or not. Otherwise, their means are different. One is 60, other is 55, third is 50. But we have to see whether it is statistically different or one. So by default, we assume that these are same. Now what happens? We have statistically analyzed, and then we find that these are different. Now when these are different, now the point here is, what is my confidence level? With what confidence I can say these are different? There I will make use of this Ti-1 error. Means I am not ready to commit more than 5% error in rejecting this null hypothesis. When I will say that these are different, I will reject this null hypothesis where I have said that their mathematics, their proficiency in mathematics is same. So how much error I am willing to commit? So I have decided my threshold that it should not be more than 5%. That it should not be more than 5%. Now when I reject this, then my alpha comes out to be 0.02. Now what does it mean? This means if I reject this null hypothesis, that there in which I have assumed that their proficiency in mathematics is same, I reject it saying that it is different. How much error I am likely to commit? Then this alpha tells me only 2%. And I am ready to commit 5%. Okay. It means with 98% confidence, I can state that their proficiency in mathematics is different. So this is how we make use of these errors. So we decide our alpha factor that if we reject our hypothesis, what we have assumed, the unproven proposition, so how much error I am going to commit. So with this basis, so I will be discussing two techniques here. So one is analysis of variance and other is multiple regression. Now, what is analysis of variance? So there is method for this, and second thing is its theory, that how we employ this. As far as the method is concerned, I will send you the slides, but let me explain to you its importance. Now, normally, how do we compare two things? Let's say you have taken two materials, for example. One is material A, one is material B. Okay, let's say you have the two types of cements, for example. Now you want to check their strength. So you have taken some observations. You have some quantitative data. Let's say you have taken 10 observations on material A, 15 observations on material B, on the strength parameter that you have measured. And now you want to compare the strength of these two materials. So what you will be doing, you will be comparing their means, for example. Now when you will be comparing their means, then what will happen? So you will see, first of all, you will hypothesize, that is null hypothesis, that both the materials have the same strength. Then you may employ the test of difference in means, T test, Z test, simple statistical test, and may check that whose strength is better or more as compared to the other. But if you have more than two samples, let's say 3 samples, 4 samples, or 5 samples, then this simple test of measuring the difference in means will not be applied. Then here you may go for one-way ANOVA, one-way analysis of variance. Now here in this case, the data what you require is, you require the interval scale data or the ratio scale data. Okay, for example, whatever the observations you make, you measure height, etc. Or in certain units where 0 is absolute, that is ratio scale data. Where 0 is not absolute, that is interval scale data. For example, we measure something on a 5-point scale, Likert scale, etc. That is interval scale data. It is ordinal scale, but converted into the interval scale. So where 0 is not absolute, that is interval scale data. But where 0 is absolute, 0 means that nothing exists. Okay, for example, in case of temperature, at 0 degrees centigrade, you cannot say there is no temperature. So that's why it is not a ratio scale data. So where 0 is absolute, that is a ratio scale data. So you require this type of data for carrying out this. Then second important thing is this we calculate F statistic out of it. Now what is this F statistic? F statistic is the variance between groups divided by variance within groups. Variance between groups and variance within groups. Now what does it mean? Now I'm going back to the same example of score in mathematics in 3 groups. Now there are three groups, A1, A2, A3. There are different students, different number of students, A1, A2, A3. Now we understand, now for example, let's say the mean score has come out to be 50 in case of A1. But all students have not scored 50. Some of the students have scored 50. Some of the students must have scored 55, or someone must have scored even 90, okay, or 100. On the other side, someone must have scored 0 also, or 10, 20, 15, for example. But anyhow, now their mean score comes out to be 50. Now the difference in the individual scores, of the students from the mean score of their class, it is the variance within the group. Okay, this is how we calculate standard deviation. That mean is 50. One of the student has scored, let's say 10. So this observation is xi or x1. Then x1 minus x bar, which is 40. Okay. Then similarly, x2 minus x bar, x3 minus x bar. Then we take their square, then sum of the squares. So this is variance. So this is the variance within the group. And second thing is, in the numerator, it is the variance between groups. So when we have to compare group A1 with A2 and A2 with A3, then we need to keep variance within group as minimum as possible. And this variance within group is called, it is an error term. It is an error term. So this variance within group is an error term. That means that internally within the group, there should be consistency. There should not be large deviations. If there will be large deviations, okay, for example, let's say one student scores 10, another scores 20, another scores 25, another scores 15. On the other side, another scores 85, another scores, let's say 90, one scores 75. Even though their mean score will come 50, but they are largely deviating from the 50 on both sides. So variance within group is very, very high. When variance within group will be very, very high, why we call it as an error term, then this will not explain appropriately the variation between the groups. So in order to, what is our objective? Our objective is that we want to see that whether A1 significantly differ from A2 or A2 significantly differ from A3 in terms of their proficiency in mathematics. This is our objective. So in order to measure this, first of all, there should be internal consistency within the group. So that's why variance within this group needs to be as minimum as possible. Only then the variance between groups can be explained. So this app statistic is basically the difference between the variance between groups and variance between, divided by variance within groups. So this is how it is calculated. So here, as far as this between group variance is concerned, so it is known as variance का जो symbol है, that is sigma b square. So this is sum of nj. Then there is some problem here. So it is actually sum of nj. Then here it comes xj bar minus x double bar square divided by k minus 1. Now, what is k? K stands for you see the number of groups, you can say. Let's say if there are 3 groups, 3 sections, so there are, you can say, 3 groups or 3 sections. So K are the number of groups. Then this is here it is within group variance. Now within group variance is sum of Nj minus 1 divided by Nt minus K, then Sj square. Now let me explain to you. Now basically, let's say we have 3 groups. Let's say in one group we have taken 5 observations. In another group we have taken 5 observations. In yet another group we have taken 6 observations. The mean score of group 1 has come out to be 70, and of the another group has come out to be 21, and of third group has come out to be 90. Now if you take the grand mean of all the respondents of all the 16 observations, then it is 90. So X double bar is, you can say, it is a grand mean. Then Xj bar is the mean of a particular group. Let's say group 1. As I have said earlier, in case of mathematics, it was 50. So there we take Xj bar minus X double bar. That means 17 minus 19. So it has come minus 2. Then we take its square. So square minus 2 square becomes 4. Then we multiply it with Nj, means number of observations in this group. This was 5. So of first group it has come 20. Similarly, let's say the mean of the second group. It was 21. Let's say Xj bar. That is X2 bar, you can say. Minus grand mean, it is 19. So it is again 2. X2 bar minus X double bar 2. Then take its square. For variance we take square. It is 4. Then multiply it with Nj, the number of observations here. It is 5. So it is again 20. Then you take third group. Let's say its mean has come 19. Grand mean is also 19. So Xj bar minus X double bar is 0. 0 multiplied by number of observations 6, it is 0. So now you take the sum of all these sum of squares. So in case of first group it was 20, in case of second group it was 20, in case of third group it was 0. So 20 plus 20 is 40 plus 0. So this is called 40. So this comes out to be 40 divided by K minus 1. K are the number of groups. So number of groups are here 3. 3 minus 1, it is 2. So 40 divided by 2 is 20. So between group variance has come out to be 20. Now what happens here? We will consider the case of all the 3 groups. So let's say the mean of the first group was 17. But all respondents have not, or all observations did not have the score of 17. First observation score was 15, let's say. Second observation score was 18. Then third observation was 19, 22, then 11, for example, let's say. So here we do this thing. So we first find out the variance of each group. So first we find out the variance of each group. For example, 15 minus 17, 18 minus 17, 19 minus 17, like this. Then we divide it with its degrees of freedom, which is n minus 1, that we simply calculate simply calculate when we calculate this variance. Now here we have taken the sum of the variances of all the three groups, taking the sum of the variances of all the three groups. So this comes out to be, let's say here in this example, let's say this comes out to be 14.75, let's say. So this variance is 14.75. Now we divide, because F statistic is the ratio between groups and within groups. So 20 divided by, let's say, 14.75. So that will give us the F statistic. So there we will see, with the help of the level of significance alpha, whether alpha is less than 0.05. So if alpha is less than 0.05, which is our cutoff, type 1 error that we want to commit, we will say these three groups are significantly differing from one another. Otherwise, we will say if alpha is more than 0.05, then we will say that we do not have the enough confidence to, to reject this null hypothesis and stating that these three groups are different. So for this, there are, to do this, there are certain softwares, and once a software is SPSS, another is Minitab, you can make use of any of these two softwares. So these are the slides relating to this, how it is calculated. Now, this is the example I have here. This is the data. Let's say here, this is the dependent variable. That is sales of the store. And now we want to see the effect of these two variables. One is coupon and another is promotion. Means people who are holding the coupon of that store, whether it promotes the sale of that store or not. Second thing is that some advertisement about the store has been given, whether it promotes the sales or not. Now these are the three types of respondents. So they have been labeled as 1, 2. Now here in this case, two types of respondents are there. So they have been labeled as 1, 2. And there are three types of promotion schemes. And these have been labeled as 1, 2, 3. So now for this, here, now as far as this sales is concerned, here I have used the term scale, that this is a scale data. The important thing is that you should be very clear about the nature of the variable. Whether the variable data is scale, means that either you have the interval scale data or you have the ratio scale data. Now the second thing that has been mentioned here, 1, 2 or 1, 2, 3. Now this score has been mentioned only to classify the respondents. Okay, for example, you have to classify in this way: low temperature, medium temperature, high temperature. So here you are not, now if you write the value of the temperature, that this much Kelvin or this degree centigrade, so this will be the interval scale data. Okay, it will let you know that how one object is hotter as compared to the other object. But if you just classify it like this, that it's a low temperature, medium temperature, high temperature, then you are basically making use of this nominal scale. So nominal scale is used just to classify. Okay, so that's why here 1, 2 are there, that those who are having coupon or those who do not have coupon. Now here promotion, so there are three types of schemes. So that's why these have been classified as 1, 2, 3. So it is not a scale data, it is a nominal data, and whereas sales is a scale data. So here, first of all, one-way ANOVA has been employed. So here in this case, in case of one-way, we take the effect of only one variable on the dependent variable. So here in the dependent variable, you may see sales, and here it is promotion. So finally, these are the steps. So after employing this, so we have computed this value. Now here you may see that what are the inferences, because machine will give you the result. Then you have to make inferences out of it. Now, first of all, you may see that this is the F value, and this significance figure is the value of alpha error, type 1 error, level of significance. If you have put your threshold at 0.05, so its value is very, very less than 0.05. It means you will be making no error in rejecting the null hypothesis, that the effect of the independent variable on the dependent variable was significant. So it was making a significant difference between the people who were having the coupon or not in terms of the sales of that store. Now, how this value has come, F. So first of all, we see that the 3 samples or 2 samples, whatever there were, these were significantly differing from each other with respect to our dependent variable that we want to measure. Now, how this value has come here? Now, this value is basically F statistic is the value of just hold on, please. Yes. So here you see that this is the between groups sum of squares, and this is the within group sum of squares. And here this sum of squares, the between group sum of squares, it is the sum of squares that we have earlier calculated, like 20, 20 plus 0, 40. And then you divide it with the degrees of freedom, which are here the number of groups -1. So if there are 3 groups, so -1. So there comes out to be this 53.033. So this is mean square. 53.033 is what? It is the between group variance. And this is the within group variance. So after the formula, then divided by degrees of freedom. So this is the within group variance, which is the error term. Now, what is F statistics? F statistics is the ratio of between group variance divided by within group variance. So when you divide this 53.033 with this 2.956, so this is how this value comes out to be 17.944. So from here, we look at this, that what was the between group variance, what was the within group variance, and then this is the ratio here, and whether this ratio is significant. Yes, this ratio is significant. It means there is the significant difference between our groups. Either these are the students, these are the respondents, or these are the materials, whatever it is, what you have measured. So you can see whether it differs or not. Now, sometimes what happens, you may have the 3 groups. So when you have 3 groups, now here F statistic has, so for example, here also there were 3 groups. So F statistic has been found very significant. Now question here is, for example, coming back to the earlier problem of 3 mathematics groups, one having a score, mean score of 40, another having a mean score of 50, 50, another 55, and yet another 60. Now we have to see whether, okay, overall it has said, F statistics has said overall that these 3 groups are not similar. These differ from one another. Now you will be interested whether A1 significantly differs from A2. Maybe a case that A2 significant, A1 significantly differs from A3, okay, or A2 significantly differs from A3, but A1 and A2 may not significantly differ from each other. So overall, it comes out to be the significant differences. Now we have to see that what group significantly differs from what group and not from what group. And for that, we carry out multiple comparisons. So, and here I have clicked this option to case. It is a post hoc test. So we may click this. So if we click this here in the software, to case post hoc multiple comparisons, that it will also let you know. Now this is a comparison between group 1 and group 2, group 1 and group 3. So this will be the same thing of group 2 and group 1. And this is the difference between group 2 and group 3. So here you may see from these significant values that what group differs from what group. So this is important to know that what group significantly differs from what other group and what not. Then second thing is the multiple ANOVA. Sometimes we have more than two variables. So we want to check their effect of two variables. Not only one variable, but two variables. Now, for example, we want to see the effect of seed and fertilizer on the yield. Earlier, we have seen the effect of seed on yield. Now, we want to see the effect of both the seed and yield. Now, we have three levels of seeds. We have classified into 1, 2, 3. Let's say we have three levels of fertilizers according to the proportion in which nitrogen and phosphate have been mixed. So we have three levels of fertilizers. Let's say. Now we want to see the impact upon yield, considering considering the weather conditions constant, considering fertility of land constant. Now here our design is very, very important. That is called factorial design. So that's why I told you right at the beginning that you should be very clear that what is your objective, what information you want to extract from the analysis. Accordingly, you have to design the format of the data collection. So here we make use of the factorial design because time is a constraint. I will not go into the deep details of the factorial design. So that's why we require the different data formats. So many times you see that you have three groups and you want to give three treatments, and you want to make it sure that each group should get each treatment only once. So you have to design. It can be Latin square designs, it can be randomized design, it can be factorial design. So that's why, particularly in experimental studies, these designs are very, very important. So here, now we want to see the effect of two variables. Now here we have two variables. One is coupon and other is, let's say, promotion. So we want to see the effect of both the variables. Now what is the important thing that we have to see here is, sometimes, now what happens, let's say, simply I put it like this, that y is a function of, let's say, two variables, let's say change in two variables. One is, let's say, A and other is B, or x1, x2, for example. Now, x1 might have its significant impact upon y. Similarly, x2 may have its significant impact upon y. But at the same time, these two independent variables may relate to each other. Means one independent variable may interact with other independent variable and may complement the effect of the other independent variable. So x1 not only independently influencing the dependent variable, but may also interact with x2 to increase or to moderate its influence on y. So whenever we make use of ANOVA for multiple independent variables, in that case, we also need to look at the interaction effect. So we test two things. One is the independent effects of the variables under consideration. And second thing we see the interactional effect. Means the change that has been caused by one variable also changes due to the change in the other variable. The change that has been caused by x1 on y also changes significantly due to the changes in x2. Means if we make any change in x2, the impact of x1 will not be as much on y as it was existing earlier. So that is called the interactional effect. So that's why here our output is like this. Now here you may see that this is the independent effect of the coupon. It is significant. This is the independent effect of promotion. It is significant. Now this is the interactional effect. Coupon into promotion. So here, this is the F statistics for this, but it is insignificant because here P value or level of significance value is more than 0.05. So we say that independent effects of coupon and promotion are significant on sales, but these two variables do not interact with each other in terms of their influence on the dependent variable. Now on the other side, I can give you another variable. Now for example, had it been the other case here, that coupon has the significant effect, even promotion has a significant impact, and this interaction is also significant. Then the independent effects of coupon and promotion, independent effects of independent variables carry no meaning or carry very insignificant meaning. Because when interaction is significant, means if x1 is influencing y1, its influence is also significantly moderated by the x2. So the influence of x1 on y carries very little or insignificant meaning because its effect is being moderated by the variation in other independent variables. So this is the two-way or multiple ANOVA. There is another test which is relating to ANOVA. It is called ANCOVA. Now, what is this ANCOVA? So we introduce C here. Now, this is analysis of covariance. Now, if you look at this data, now here there is another factor, that is rating. That rating of the store given by their existing customers or customers who had visited in the past. So we have not considered here. Now, sometimes what happens, it may also influence the sales because I went to that store earlier. I had spread the positive word of mouth for that store. That's why people are also going to the store. So how can I establish that it was the effect of this coupon or promotion only? Now, what does this mean? These are called the confounding variables. So whenever you carry out any study, particularly experimental study, you have to be very careful about this thing, that whether there are any confounding variables. What are those confounding variables? These are the variables which are not the part of your study. Okay, these are the independent variables which are not the part of your study, but may have a very significant impact upon the dependent variable. Then the biggest issue becomes before you to control this. Okay, first you have to see whether it is significantly impacting or not. If it is significantly impacting, then you have to make your research design in such a manner so that its effect is diluted. Either you go for randomization so that if its effect is there, it should be uniformly spread so that it should not skew your findings in a biased manner. So in order to check this, whether there is any covariate available there, which may significantly impact or not, so you carry out the analysis that is called ANCOVA. So this is used. Now simple thing here is that here in this two-way ANOVA, so we may add this rating also here in the covariate, and then we may see whether our results are affected or not. So this is all about analysis of variance. Now in the rest part of the lecture, I would like to share with you some insights on regression. Just hold on, please. Now, first of all, let me explain to you about the importance of regression. Multiple regression is very much used in almost all types of research areas or problems. Now, what is this multiple regression all about? Basically, this is used to see the effect of number of independent variables on the dependent variable. Now, for example, let's say y is the dependent variable and there are number of independent variables. Let's say x1, x2, x3, x4, x5, like so on. So first of all, we constitute a regression model in which we see that the dependent variable which is under consideration, how it is being influenced by what type of variables. Now, how do we come to know about this thing? This thing is suggested by the theories. This thing is suggested by the conceptual framework. From the literature review, we come to know that the variation in the dependent variable by and large occurs due to these many 4-5 factors like this, which are your concepts. So this is how we want to establish cause and effect relationships. Now in this case, when you have the multiple independent variables, so we want to see their effect on the dependent variable. So we employ the multiple regression. As far as the correlation is concerned, correlation is used to see the association. Okay. So it is also related to this, to see the association between the variables. Now here we try to establish the cause and effect relationships. That if we make a change, let's say of 1% in x1, how much change it will bring into y. So whether x1 significantly influencing the variation in y or not, If we have to test this, then we make use of this regression equation. Now, basically what happens, let's say you have a mean score, let's say 50. Then there are some individual scores, which are your individual observations, and these are different from the mean score. Let's say one such observation is, let's say 40 or 35. Now there is a deviation of 15 units from 50 to 35. Now in between there comes your regression line. It can be a linear also, it can be logistic regression, which is used for curvilinear relationships. Now we will see that how much variation is being explained by this regression model. Let's say this difference of 15 units from 50 to 35, how much it is explained by the regression model. Then the remaining deviation, which is unexplained variation, it is the error. It is the error, standard error of the estimate, which is not being explained by your regression model. Let's say you have carried out a literature review and you have developed a model where you want to test the variation in one particular, let's say, or one particular parameter. And from the literature, you have come to know that this change is occurring because of these 4 factors, by and large. So you have designed your research and research problem based upon these 5 things or 5 factors. One is the dependent factor and other are the independent factors. Now, if these 4, now for example, I am taking the previous example, let's say yield. And the agricultural scientist says that this yield is being affected by, let's say, only 3 things. One is seed, another is fertilizer, and third is, let's say, the fertility of soil. And he said, by and large, yield would depend upon these 3 things. And if he finds that these three variables, independent variables, are sufficient enough to explain the variation in the dependent variable to an extent of 80% and above, then this is a fit regression model. It means there is 20% unexplained variation, which may occur due to some other factors. So we may not bother about this thing. We may largely say, yes, main variation in this dependent variable is caused by these 3 factors. But if it explains only up to these 3 variables explain variation only up to the extent of, let's say, 40%, 50%, it means 50% variation is unexplained in this model. It means we have skipped very important factors, some of the important factors in our research analysis that would have probably caused significant variation in our dependent variable. So first of all, we have to see through this regression model whether our model of research is a good fit model to carry out research or not. So these are the statistics. For example, here I am taking a very simple example. It is already there. So I am sharing the same thing. Now this example is relating to the body mass index. Now there are certain factors that this body mass index depends upon some individual characteristics, individual behaviors, environment. So based upon these, some variables have been identified. All these variables relating to these 3 factors have been identified. So these are the variables, and these are the respondents whose body mass index was first observed. Okay, that is the dependent variable, and these are the independent variables. So finally, this regression equation has been formed. Okay, now this is the value of the intercept. So number of calories, how much exercise the person does, gender, income, education, built environment, and this E stands for the error term, that is unexplained variation. So finally, using all these steps in the in the any you see in the software, either BT tab or this. So these are the descriptive statistics that I would like to discuss with you. The very first thing that we see here is that how much variation has been explained. Now here variation is this R square value or this adjusted R square value. Adjusted R square value simply basically this value is adjusted on the basis of the number of input variables or independent variables we have. So where it comes the maximum, that means that is a good fit model, that whether you should select 3 independent variables, 4 or 5. So where it is maximum, that is a good fit, you can say. So here it explains that 60% variation in the body mass index is being explained by these select factors. It's a good enough as far as these sociological sciences research are concerned. So it is good enough. Now, second thing, what we need to see here is now this basically, this table. Now from this table here you come to know that there are some unstandardized coefficients and these are standardized coefficients. Now what are standardized coefficients? Standardized coefficients are those coefficients where the values of the coefficients, for example, coefficients, these are the coefficients. These are coefficients, beta 1, beta 2, beta 4, beta 5, etc. So these coefficients are unstandardized coefficients. And then these are standardized. Now these are standardized to zero mean, standardized with respect to what? These are standardized with respect to zero mean and 1 standard deviation. And why it is done so? Because you have the different variables and different variables are measured in different units. Okay, food intake in calories, there are different units. Exercise, there are different units, for example. So different independent variables are measured on different scales. So these are standardized with respect to zero mean and 1 standard deviation. And then we look at this value SIG. It is again alpha error value or level of significance value. Now here you may see that if you look at the calorie, so its standardized coefficient is 0.753 and it is significant, value is less than 0.05. Exercise, its value is minus 0.163. It's also significant. And negative sign indicates the inverse relationship. Okay, more exercise, less body mass index, like this. Then third, we have the income. So in case of income, here you see it is slightly more than 0.05. So you may extend your threshold also if your literature states yes, it makes an impact. Otherwise, you may reject it. And here you see education. In case of education, this beta value, standardized beta value is very, very less. And it is insignificant also. It is very, very value is of alpha is very high, that if you will be rejecting the null hypothesis that education has no impact, it means, education has impact. So you will be having only 7% confidence. So finally, from here, we come to know that these three or these two, calorie and exercise, these are significantly impacting upon the body mass index. And these are explaining 64% variation also. And out of these two, which has the highest impact? So that we can see from the magnitude, not from the sign. We can simply see from the magnitude that, for example, calorie intake is impacting upon very heavily on the body mass index. So here we come to know that which variable or which factor has the highest influence, followed by what variables. So first of all, we see what variables have the significant influence, and out of the variables having the significant influence, what variable has the highest influence, and followed by what other variable. Then third important thing, from this sign we can see that how the variables are related to the dependent variable. So whether there is a direct relationship or there is inverse relationship. Now, what is the biggest limitation of this method is? The biggest limitation of this method is sometimes these variables, independent variables, may not be independent in the true sense. They may be correlated with each other. They can have the correlations. Okay. For example, if X1 is making an impact on Y, so you may be misled if you see that or say that X1 is contributing to Y. Okay, X1 must have been contributing to Y because X2 is interacting with X1 or X2 is complementing the effect of X1. It is not the effect of X1, but it is the moderation of X2 on the effect of X1 on Y1, okay, or on Y. So that problem is called the problem of multicollinearity. So that's why in this case, we have to check the correlations between the independent variables. So these are the multicollinearity values. So certain checks and these values, threshold values have been given. So for example, if the value is, you can say up to 15, so it is tolerable. But if this condition index or collinearity index is very high, more than 30, then you have to see that which variable is actually contributing to the effects of the other variables, or it is correlated to the other variables. There you have to check the independent correlations between the variables. Okay, and for that there is another technique that is called you can say the partial correlation methods. So for example, if you have to see the correlation between the independent variables, let's say 3 independent variables, so there you see the partial correlations. For example, checking the correlation between 1 and 2 and fixing 3. Similarly, checking the correlation between 1 and 3 and fixing 2. Then you come to know that which variable is highly correlated with the other variables. Then you go back to the literature that if I skip this variable out or if I skip this factor out, can I carry out the study? If that factor is not of any significant importance, you may either skip it, or if it is of significant importance, then you have to go for some other techniques like factor analysis, structural equation modeling. So these are the further advanced techniques of data analysis. So this is all for today's lecture from my side. Yes, any question, anything you want to ask? Yes, please.
Sir, I think there is a no query.
Hello.
Yes, sir. Are you getting the voice? Hello.
हाँ जी सर, आवाज थोड़ी मध्यम है. हेलो. हाँ जी, हाँ जी, हाँ जी, हाँ जी. Yes, 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 please.
हाँ जी sir. Sir, we are very thankful for this valuable information.
Okay ji, thank you,
And,
thank you.
we
So
will
in whatever
wait,
time available with me, so what I could do with that to my best in that constraint. So if I have skipped something, I really feel sorry for that. Okay, so
no,
yes,
sir, it's
please.
very good. Sir, I already heard your lecture at Guru Nanak Dev Engineering College, Ludhiana.
Okay. Thank you.
Sir, basically, I am the alumni of Guru Nanak Dev Engineering College.
Ji.
So, near about 4 or 5 years ago, I hear your lecture there.
Okay, thank you.
Sir, your village is also near to my village.
हाँ जी, सियाड़ पिंड है जी मेरा.
मेरा कढ़ानी कलां जी.
Oh, wonderful. So nice of you. So good. आयो कदे मिले हो हैं जी गोपाराय साहब. हाँ जी.
Definitely sir, definitely.
ठीक है जरूर आयो.
हाँ जी sir, definitely sir.
ठीक है जी.
सर ओके जी, फिर समाप्ति करिए सर फिर अपन.
हाँ जी, ठीक है जी. ओके जी.
ओके सर. Thanks for joining.
Thank you.
Okay, sir.
Thank you. So nice.
Okay.